Okay, I appreciate everyone showing up tonight. Dale, if you want to take over and introduce yourself, because there's some newer people here, go ahead.
Okay. Well, my name is Dale Chamberlain. I don't know, I guess I've been a part member of the ASEM now for what, maybe a couple of years or so. I have been in astrophotography for quite a number of years. I have my own backyard observatory, and I'm retired, so I can spend more time on this. I used to be the chief technology officer for Express Scripts years ago. So I have been attending these Masters in PixInsight. If you guys, any of you guys are PixInsight users or looking to become more fluent in PixInsight, I think Masters of PixInsight does offer some good training courses, and they're relatively inexpensive. But I first went to Kit Peak Observatory back in 2019, and I had been using PixInsight for quite a while. Pretty much self-learned, and if anybody's been down that path, you know how high the learning curve is for PixInsight. But I went to Kit Peak, took their intermediate astrophotography course, and spent the weekend up on the mountain and learned a lot more. And then since then, I've been doing the Masters of PixInsight. So I think that one of the things that I'm going to mention in this presentation is that, my workflow, my post-processing workflow has changed so much since those early days, and it's changed considerably in the last year. And primarily because there's so many new tools out there that really make the job better and easier to deal with, I think. So I'm going to start off tonight with a brief presentation that's just going to talk about artificial intelligence in astrophotography. And then after I go through that, I'm going to switch over to demoing some steps in PixInsight using some of these AI tools. So I will, let's see here. I want to make sure I get the right thing. And just let me know when you see my. Okay, you see the title?
Yes.
Okay, good. All right. Just gotta get over here to where I can control it. Okay, so as the title says, this is all about well, come on. It's all about artificial intelligence, and hopefully the slide just changed. Do you see a different slide now?
Yes.
Okay, good.
Sorry.
All right, so I just want to start off kind of with a definition, and this comes from Intel Corporation. What is artificial intelligence? And actually the term artificial intelligence as it's being used in computers these days is just not really accurate. But what it's, and according to Intel, these are machines that are capable of perception, logic, and learning. And I think that well, we all know the computers can do logic, but the learning aspect of it is probably the key point in going through this. Machine learning employs algorithms that learn from the data to make predictions or decisions, and whose performance improves when exposed to more data over time. And that is probably the keystone right there for AI. So no matter what you look at, and in particular with the tools that Russ Kroman has come up with, it's been about developing these algorithms that are derived from data, in which in this case, depending on what problem you're trying to solve, you're trying to get rid of noise, you're going to start with an image that has noise in it, and you end up with an image that has no noise in it. And you have enough of these together to train the AI network so that it knows what to look for. And deep learning uses many layered neural networks to build algorithms and can find the best way to perform the task on their own based upon vast sets of data. And the larger the data set, the more improved the processing can be. Now, in photography, so there's been many examples of AI in photography, and it allows the developer to focus on solving the problem rather than coding for it. That's probably one of the key pieces that AI as a development means has been crucial. In the past, we've always had developers writing code. Well, this is a situation where we're trying to focus more on the problem using data. And AI has been a part of digital photography for some time now. So examples are Photoshop, Creative Cloud, Topaz Denoise AI, Gigapixel, Sharpen AI, DxO Deep Prime. Those are all commercially available products that have been in the photographic community for quite some time. But there's also, and this is one of the things I want to make sure I get this point across, is that in graphic arts, there are tools out there that can build images based upon a lot of different images, including stock images, which has been kind of an issue, I think. It's not true photography. And I know I've had this discussion with the people at the St. Louis Camera Club. They don't regard it as true photography. They regard it as graphic arts. So you have tools like Midjourney, Stable Fusion, and many others out there where you can give it a narrative of what you want to produce, and it will create, based upon its collection of photos, an image that corresponds to your description. That's not what we're talking about here tonight. So I want to make sure that we're clear on that. Now, AI in astrophotography has been lagging, and it has lagged the photographic industry quite a bit up until now. Now, many astrophotographers used Topaz Denoise AI. Topaz Denoise does an excellent job for non-astro photos, but lacks certain features that are needed for astrophotography, primarily because I don't think that's been the key focus of the learning method of the AI. They were not trained. I mean, they may have some astro photos in there, but that's not been the core of the training of those AI neural networks. Now, Russ Croman's RC Astro introduced the AI to astrophotography. To my knowledge, I mean, I may be wrong on this, but I don't know that anybody has, I don't know if there was actually a true AI for astrophotography before these tools came out. So he's got Star Exterminator, which was one of the first ones that came out with, which its task is basically to take a deep sky image and separate the structure from the stars. And then there's Noise Exterminator, which goes through and actually cleans up any noise found in the picture. And then most recently, the Blur Exterminator, which is the deconvolution module of what Russ Croman has developed. All of them use a neural network built upon carefully selected astro images. So there's nothing in, these were not trained to take somebody else's image and replace data that is missing in your image. And it's continually learning from new images over time, and Russ will release this to the user base's new databases. So I would say that So if you look at what the developer is allowed to focus on, is focusing on solving the problem, such as solving the problem of noise reduction, solving the problem of deconvolution, solving the problem of star recognition, rather than writing code. So think of it as a different approach to solving the mathematical problems that we face in digital image processing. It eliminates the tedious guesswork in running the traditional PixInsight process. So, you look at most of the old style processes that have existed in PixInsight for a long time. They rely upon masks, wavelet layers, switches, dials, all sorts of things. And you have to keep tweaking these things to get it to where you want it to be. The AI will yield much better results in much less time. And it's virtually free of processing artifacts. And I know that's one of the issues, that you can over process something in PixInsight and you'll start to see artifacts. And it is using your image data without replacing any part of it with another image that's not yours. So, so we want to talk a little bit about deconvolution, which is about recovering fine scale image signal that's buried in low contrast. It is not large scale recovery, such as the multi-scale functions in PixInsight do. And Blur Exterminator only recovers detail if the detail exists in your data at low contrast. So that part needs to be emphasized, that if the data is not in your image, it's just not going to come back. It's not going to be there. So the data has to be there. It could be buried in this low contrast. And what Blur Exterminator will do is pull that out as much to the best that it can. Now, I'm going to spend a little time on Blur Exterminator, because this probably has been the most important one of the modules that Russ has come up with. It's really put him on the map. Now, even in the old style PixInsight deconvolution, if any of you have ever tried that before, it's very old. I don't think it's changed in 13 years. It relies a lot upon masks, and it relies pretty heavily on the point spread function to create a mask so that it knows how to deconvolute the image. Now, when I say deconvolute, I'm not talking about sharpening. There's a lot of times people will confuse those two. Deconvolution, and Ron Breacher has probably got the best analogy for this, is that it's like you got a cup of coffee, black coffee, and you pour cream in it and you stir it up. Now you want to get the cream out and get it back to the black coffee. That's kind of like what deconvolution is trying to do. It's trying to clarify the image. So what happens is, and then you all know, you've all been in the astrophotography arena for quite some time. I'm sure that you know that what we do is always about trying to eliminate the things that are interfering with our image. For example, dust spots on the sensor, vignetting caused by the telescope, atmospheric distortions. There's a whole host of things that can affect the quality of the image. And if we're imaging on a particularly bad night with a lot of humidity, a lot of heat rolling in the sky, we know we're not going to get the best image we possibly can. And so if you think about the stars that we're imaging, is a very, very tiny point of light. And by the time it gets in, if you look at this cone that I've got over on the side, hopefully you can all see that. The star is a very, very tiny point. It's going to pass through the atmosphere. It's going to pass through your optical train, and you're going to have some guiding errors that all going to contribute to this widening of that tiny little spot of light. And that's the point spread. So what we're trying to do is narrow this down in the deconvolution process as close as we can to where this little point of light is. And so every deconvolution process will rely upon the stars. And it will calculate what that point spread function is. Now, deconvolution is never perfect. It reduces the spread of light captured on the imaging sensor, but it will give you some clearer structures and tighter stars. The PSF is expressed as the full width half medium value. So keep that in mind as we go through this. Now for hardware, this will run on any Windows, Mac, or Linux platform. It's easy to install in PixInsight. Updates are automatic. Windows platforms with a NVIDIA graphics GPU will speed up the processing significantly. I've got a link later on at the tail end of this presentation to some instructions that Russ Croman has on enabling CUDA support. If you have a Windows machine with a NVIDIA graphics GPU, I highly recommend that you enable CUDA. It's a bit of a tedious process to do, but it will make a tremendous difference in the processing speed in your computer. Now, my particular image processing computer, it's an AMD Ryzen 9 5950. I've got 32 logical processors, 128 gig of RAM, NVMe storage, and a NVIDIA RTX 3080 graphics card. So that's just my configuration. I wanted to go for, some big honking hardware to go through all of this stuff. When you're dealing with AI and the neural networks, you've got to have some really good CPU. The GPU is really where it comes from. Now you've got to make some considerations for workflow. Now, blur exterminator should always be used early in post-processing. So after you've integrated your images and you've done your channel combination, cropping, your dynamic background extraction, or there's a new tool out there called Grexpert that comes out of Germany. That I think in fact, I've started using that in my workflow. It's actually, I think, does a better job than DVE. Color calibration, all that should be done before you do any kind of noise reduction and while in a linear state. So the reason for that is when Russ built his AI training, it was performed on images before noise reduction. Now, whenever I've done the old deconvolution process, I've always done it very early in the process before noise reduction. And I've always done it on a luminance image. And you'll see that when I go through the process when I demo that. But I always did it on a luminance because that's where all the details of the structure exist. The color, there's things you can do with the color side of this thing, the RGB, that will help enhance the stars. But the real guts of clarity exists within that luminance layer. Now, and Russ will say this in any of the presentations if you've watched any of them. It's most accurate if you give the full width half medium of the image rather than relying upon the auto PSF. So what that means is that he has an auto PSF function. If you check that, it will automatically go through and try to figure out what the PSF is. But he says there's a slightly better accuracy level if you do it yourself and then feed that into Blur Exterminator. Now, I use the Hartmut-Bornemann PSF image script on an RGB, but I really use the PI's full width half medium eccentricity script on monochrome. Because I said again, we're going to do this on the luminance. That's going to be a monochrome image. I use it on the luminance, either acquired or extracted. And it can be used on RGB. The new revision allows for a selection of luminance only for RGB images. But the big thing here is LUCMA, no masks. Now it can correct aberrations caused by guiding errors, astigmatism, primary and secondary coma, chromatic aberrations, and varying full width, half, medium star diameters and halos in each color channel. And I think that's a big one right there, because all those aberrations can go away with the use of blur exterminator. Noise exterminator, use that while it's in the linear state, immediately after doing blur exterminator, and then again after you do a permanent histogram stretch in the nonlinear state. My old process was to do two noise reduction phases. One was in the linear, one was in the nonlinear. I still stick with that, and because I think when you do a stretch, you're going to introduce some noise factor. So might as well just hit that one more time to get rid of it. And then the star exterminator, it can be used anytime when processing is better on a starless image or when a star mask is needed. It can be done in linear and nonlinear states. And it's recommended to use the unscreen mode if reblending stars back into the starless image. So you can use star exterminator. It separates the structure from the stars, gives you two images. You can set it to give you two images. And you could do processing on the image part that is without the stars. But if you want to add the stars back in, particularly if you took RGB stars, we want to add those back in without worrying about any of the other processes affecting them. There's a pixel math function, and this is the formula for it right down here. So it's I'm not going to explain what all this stuff is, but this is done in pixel math, and it's going to use both the starless and the stars only image to bring your stars back in. And then I have links here. This is Russ Croman's RC Astro site. If you go there, you can find information about all three of the exterminator functions. Back in May, Russ did a presentation to the AIC out in San Jose. I was there when he did this, and I was so intrigued by it. Anyway, if you weren't there, you can look at this YouTube video and see what he gave, how he delivered. He does a really in-depth discussion about artificial intelligence. He did an interview here recently with Adam Block particularly about blur exterminator. And then the RC Astro page for how to set up GPU acceleration is right here. And of course, here's the site for PixInsight. If you want to download any of the Hartmut-Bornemann scripts, this is where you go. I also have my own website, and I put a page out there that talks about the new processes that I've encountered within the last year that helps improve image quality. And then I also included in that a before and after slider that you can see how these things have really improved objects. And I'll add one other thing. Is like whenever I did deconvolution, which was not every time, I usually did it on nebula images. But with blur exterminator, you can do it with globular clusters. You could do it with galaxies, and it works great. Okay, so at that point, I don't know if we want to stop and maybe ask a few questions before I go on to the demo.
So Dale, I have one question.
Yeah.
And I don't know if you're going to talk about this, but it's a question that's been on my mind. Is it seems that the deconvolution tool serves some of the same effect of just being in good tight focus. So would you say there's any kind of linkage between those? You know, getting your instrument focused right. Is one of these tools, well, I guess deconvolution particularly, is that going to substitute for being out of focus or not?
No, I would not say it substitutes for it at all. I think you're always better off to try to get the image captured in the camera the best that you can, which means the best focus you can. That just means then when you go to post-process, your image is going to be that much better. What deconvolution is going to do is just try to get rid of the normal stuff that happens between the object and the camera sensor, and try to eliminate as much as it can, those distortions. But if you started off with something that was not in good focus, Blur Exterminator is really not going to help you that much.
Well, that makes a ton of sense. Just that to the eye, it kind of looks like they're doing a similar sort of task, but it makes perfect sense that you would not, get away with that.
Yeah. And likewise, there's sharpening techniques that you would do probably later on in the post process. Those don't go away either. What you do, think about this as just a replacement for deconvolution. For Blur Exterminator, it's a deconvolution replacement. It does not replace sharpening, because deconvolution is not sharpening. Yes, if you're familiar with Photoshop, it's more along the lines of clarity. There's a clarity function that I know it's within Camera Raw. All right.
Thanks.
Yeah, I had a question. I'm kind of new to all this. I've only been using PixInsight site for about a year, so I never did deconvolution the old way. I've read horror stories about it, but never tried it. The thing I really like about Blur Exterminator is the removal of chromatic aberration and for non-flat fields. Is that something that the old deconvolution did, or is that something that he knew he introduced to that?
Deconvolution will do some amount of star fixing and it'll help to round stars that are not round. But to really get the old deconvolution to do the best job that it can, you really got to play with that and spend a lot of time. And you're trying to get that point spread function in there right. And the problem I always had with it is what it does to the stars. Good deconvolution is going to shrink those stars, so it's going to affect the shape of the stars and get rid of some of that aberration. But the problem I always had is that you get those raccoon eyes around the stars, and that's when you start having to fiddle with the sliders all the time. And it just got to be so tedious that I just ended up throwing my hands up in the air. I even started doing a deconvolution with a starless image, but I would take the PSF with the stars and then apply the old style deconvolution against the starless image. And I got better results. I mean, at least it was a little, I wasn't spending hours and hours to try to tweak the thing to work where it was going to work right. But when Blur Exterminator came along, man, that's just a snap. And you'll see that in the demonstration. Anything else? All right, so now I'm going to try to go over to my imaging desktop. Hopefully this will pop up.
Okay, we can see it.
Okay, good. So what I have here, this is M16 that I took back in July and August of 2021. This is the hydrogen alpha here. And then the sulfur is here, and oxygen is here. Okay, so in this example, what I did, and you don't have to do it the same way, but what I did was I used the Gray Expert on each of the mono frames. So I got the you know, so it's the equivalent of the dynamic background extraction. So at this point, I have then combined those into a color image. So at this stage, this image here has had it's been cropped. It's been you know, the dynamic background extraction has been performed, and so everything is up to the point of doing the what am I thinking of here? Okay, doing the color calibration. Now, some of you already probably know this, but you know, they've recently changed how color calibration works in PixInsight. So you know, you can, if you use the weighted batch pre-processing to stack your images, there's a little check mark in there that you can say to do basically a plate solve. It's just going to try to come up with the astrometric data. I don't even bother with that, because by the time you do your cropping, you know, or if you do any rotation of the image, all that stuff, all that information gets deleted. So you're back to square one. You need to reapply it. So now you'll see that I'm a big proponent of these process icons. And this is my standard set that I use all the time. And when I have even some of the scripts that I use, I plug them into a process icon. So I can lay this one right on top of that image, and it's going to go through and plate solve it. What you have to do now when you do a color calibration in PixInsight, all of the color calibration routines require to have the image being solved. Okay, so now that's worked, and I'm going to do the spectrum photometric color calibration. This is set up for narrowband when I use the Chroma 3 nanometer narrowband filters. And I'm using a Sony 571 chipset. And whenever you want to do narrowband, you set this, your white reference, to photo flux, and click this narrowband filters mode. So I'm going to run that, and it's going to do basically the color calibration on this image. That's the last step before you do blur exterminator. Okay, now it's going to look funky, but that's all because of these color channels. And I'm going to disconnect that and do a boosted stretch, and you see this is what you end up with. Now, okay, so at this point, I want to now determine what is the PSF for this image. Well, actually, before that, I need to extract the luminance. So I have a process icon up here. I'll just show you what this does. It invokes the RGB working space followed by the channel extraction for luminance. I always do the RGB working space before extracting the luminance. That way the red, blue, and green channels are all balanced to one another. So I apply that to here, and I'm going to get in the linear state. Let me do a boosted stretch. So here's the luminance that I extracted from that. Now this is what I'm going to work on for deconvolution. So to get that, to do that, I got one more step. I need to do this. I need to figure out what the full width half medium is on that image. So I bring in this is that Hartmut-Bornemann script. If you don't have this, won't be in your standard PixInsight configuration. You just need to download that or configure it in your resources for PixInsight, and it will download this automatically along with other scripts which are very useful. Click on measure. Okay, and you see here it says 7.255. That's what which is kind of bad, but now I have two process icons configured here for Blur Exterminator. One that's going to be for the luminance image, which is what this one is. And I'm going to bring this up so I can show it to you. For the most part, the defaults work. I have not found any real reason to mess with these. There's two sections. There's the stellar adjustments, and then there's the non-stellar adjustments. Now here, this is dealing only with the stars. The default is 0.25, which is the amount to reduce the diameter. And this is for star halos. If you've got a problem with bright halos around your stars, you can try to adjust it with that. But for the most part, I think this works fine. Now notice this automatic PSF that I talked about in the presentation. I've turned that off. I don't want Blur Exterminator to figure that out because I've already figured it out. And I'm going to plug that number right in here. And I'm going to leave all these others unchecked. Now it has a preview option, which is kind of nice. First time, it always takes a little bit of cycles to get that up there. Let me try to zoom in on that. So this is with the Blur Exterminator. This is without. Do you see the difference? So you got some nice star shrinkage there. Tightens them up nice. And the structures are looking a lot clearer. That's as simple as it gets. If I took this in through PixInsight's deconvolution, we'd be here for the rest of the evening. Okay, so now I can click that and tell it to do it on this image. Again, this is the luminance image, and the reason why this is important because this is where all of the clarity and the sharpness and all that stuff exists is in the luminance layer. Now I've got the color, the RGB. But here, I don't want to really do any kind of deconvolution on the structure. I've got a second process icon, which does a correction only. Now notice that when you click this, correct only, automatic PSF is automatically clicked, and the sharpened side goes away. It's grayed out. So all we're really doing here is fixing the stars up for any kind of aberrations. So I'm going to do the same thing here. I'm going to show you. Do this. Zoom in on this part of it. And so you can see what it's doing. You see how there's a glow or a color cast on these stars. When I turn that on, it goes away. So it's actually going through layer by layer, red, green, and blue, and trying to line those up so that it can get rid of those color casts. I'll apply that to this. And believe it or not, I am using the CUDA modification, so I'm using the GPU on my computer to process this. And when that happens, I'm not kidding you, by overhead lights and the room start blinking. Okay, so we have now deconvolved these images. And so now I can do a linear noise reduction, which I have down here. This is using Russ Krollman's linear or using noise exterminator. So I'm going to apply that to this. Okay. And then I'm going to do the same thing for the luminance.
You might open it up to show us what it looks like. The actual noise exterminator screen or dialog box.
Yeah, it's very simple. Again, I just take the defaults. Denoise is at 0.90, detail is at 0.25. I find that works well enough. I mean, you can play with it if you want. You might have some cases where you can get improved results by adjusting those, but so I'm just going to run that on this. And it gets rid of the noise in the luminance. Okay, now I am ready to do a permanent stretch. And let's see here. We're going to go back down to my screen transfer function. This is how I do it. There's a number of ways of doing this, but I do a shift and then this little radioactive button down here, which does a boosted stretch. Then I bring in a histogram, track it on that image. If you take this new instance triangle and drag it to the bottom of the histogram, it sets the histogram transformation parameters to be equal to what the screen transfer function did when you're seeing it on the screen. Now, when I go to click this and tell it to process that luminance image, it's going to turn white. That's because I still have an auto stretch in place. That's fine because I can turn the auto stretch off here. Now this is a nonlinear image. You got to do the same thing for this one. We'll just clear out of that, start over. Track it. I'm going to do a boosted stretch and drag that over to the bottom of the histogram transformation. You can see this curve here. Now my defaults for the screen transfer function is set to like a 0.1 for the background. So that's probably, you know, a good. That's what it's too dark for the background, then you can boost it up from there. But I click that and unstretch it, and you guys hear me okay?
Yeah, you cut out for just a second, but you're back.
Okay, so yeah, I got a message that said my internet was unstable. Okay, so now we have the luminance and the RGB are stretched. Now I want to do is recombine the luminance to this so that I can get the true effect of what the blur exterminator did. Now, I don't know if you all saw that change. I can, let me, I don't know if that's going to work. Oop, nope. Yeah. Okay. This is before. This is after. Before. After. You see how that's cleared that up? So essentially, I'm applying the what I did in deconvolution with blur exterminator on the luminous got added back into the RGB, and now I'm seeing the structure sharpen up quite a bit. Get rid of that preview. Okay, so now you've seen blur exterminator in action, you've seen noise exterminator in action. Oh, and then the other step I mentioned before is I always do two linear or do two noise terminators. One when it was in a linear state, one was in a nonlinear state, because anytime you do kind of any kind of histogram transformation, you're going to probably introduce a certain amount of noise again. So it's always good to hit it that second time. So I have this process icon nonlinear noise exterminator, which is, there's no difference. It's just the same thing again. Early version of noise exterminator did have a linear versus nonlinear checkbox, but Russ did away with that. He has it where it automatically detects what it is. So apply that, one last cleanup, and so right now it doesn't look too bad, but now, so I normally, how many of you are familiar with Bill Blanchard's pixel mat scripts? Now that's a link that I put on that presentation page. So I found that I struggled a lot with processing SHO palette, trying to get it the way I wanted it to work. Which all use, they're all variants of pixel mat. They all rely on pixel mat. When I got a hold of these things, I mean, now, it works best if you do it against a starless image. So I'm going to take this where I'm at right now, and this is star exterminator. So I generated the star image, and I'm also going to generate the unscreened stars. That means I'm going to plan on, anytime you want to add those stars back into your image, after you've done processing on the starless image, you want to say unscreened stars. There's an elaborate discussion about that goes back to Photoshop, where they have a screening function. It's, I don't fully understand it myself. All I know is it does a better job of reintegrating those stars back into your image. So I'm going to apply that to this. Now, Star Exterminator is one that really takes advantage of the, and right now my lights are blinking. This would have taken probably 15 minutes if I wasn't using CUDA. You can see how fast it's done. So I ended up with an image here that's got all the stars. And I've got same image, but no stars. Now I can, oh boy, it's giving me trouble on my internet again. Hopefully you can still hear me.
We can, you were cutting in and out at times.
Okay. If you look for Bill Blanchard's stuff, he's got a YouTube site. There's one called SHO normalization. Now, what this is all about is if you're using the SHO color palette on narrowband, it will try to fix the red, the green, and the blue so that they're all pretty much of equal intensity. To get the true balance of colors within an SHO image, you need to have a good balance, a good amount of intensity is being consistent amongst all three layers. So SHO normalization, that's one of his process icons. And I'll show you what that is. This is just a pixel math expression. Don't ask me what how he came up with this, but this guy, he is a master of pixel math. So that's for red. This is what it does for green, and this is what it does for blue. So you see all these formulas. It's all dealing with digital mathematics. Now watch what happens here with this image when I apply it. See? You start to get more of the golds and the browns. Still got some of the blues in the background. I find this has changed dramatically my whole workflow. I don't rely upon hue well, I do rely upon saturation, but as far as hue, I hardly ever touch it now. Whenever I used hue curves in the past, I would introduce artifacts, and I hated that. This pretty much keeps you out from doing that. Now, everything's fine except we need to get our stars back, and our stars are up here in this RGB stars. So I have a process icon that had that formula that I listed on that presentation. Add these stars back in using that on-screen mode. File RGB stars, which is and you see the star. So from here on out, you do whatever you normally do for your post-processing steps. You know, if I see too much magenta, I've got one here that's called remove magenta stars, which basically invert the inverted for magenta. Magenta is basically inverted green. And then if you had HDR, I've got some mask processes for that. I also do this LHE to help improve the contrast. And the sharpening is down here with this MLT sharpen. That still uses the multi layer transformation. Hopefully Rust will have a sharpening tool at some point in the future, in which case that would eliminate all of that. I don't know if there's an interest at all in any of these process icons. I suppose I could probably put those into a folder and share it with you. Yeah, then I go through the dark structure enhance, exponential transformation. If I want to adjust the color some more, maybe put a little bit more punch to it, I'll do that through the curves. And then down here at the color profile, I'll add that. I'll just drop that on there. All that's going to do is just sets the color profile as RGB, which is anytime you want to distribute your work on the internet, or you want to have it printed professionally, you want to make sure that your color profile is set to sRGB. Oh, and then there's also, these are also some Bill Blanchard scripts that work for star reduction, all based on pixel math to reduce these stars even further. I think I'll just go ahead and show you what that one looks like. This is another one where Star Exterminator comes in handy. I drop that on there. You see how these process icons make it a lot easier, right? I find I just set them the way I want them, and I just go ahead and use them, drop them on the image. And there's another starless image. And then I just drop the star reduction method 1. Oh, hold on, I gotta get this out. So here's the image with the stars the way they were. And we did get some reduction through the deconvolution through Blur Exterminator, but this will give us even more. See, drops them down. I don't know if you saw that on the screen or not, but kind of gives them a touch. I think it looks a lot better when the stars are a little bit smaller. Okay. That's about all I've got for the demo. And then one last thing that I wanted to show, if we got time, is let's see here. Trying to figure out where's that. Let's see here. So one of the links that I provided was to my website. And I had some of these images. I don't know if you can see it now. But before and after comparison. So these are some older images that I had processed and then reprocessed using some of these new functions that I just went through tonight. And you can kind of see, like, this is the old, this is the new. So you can play with that if you want on my website. And this is the old and the new. Now, some people will say, well, wait a minute, you had some brighter colors, punchier colors in there. I said, yeah, but I think the real intent here is to show that you can see here where the pillars of creation look a little blown out. Here they're back to normal. These are all using the same masters. In both cases, they're using the same masters, but just different post-processing techniques. This is Malot 15. I think, you can see there's a lot sharper, a lot more contrast, a lot more detail in the structures. And then this is one that really I thought helped to demonstrate using, and I've never used before this, I've never used deconvolution on a globular cluster. This was the before, this is the after. Brings out a lot more detail because that's all been buried. And then here was an example of a galaxy. This was one that I never even posted it before, but after I processed it, I thought, huh, not too bad. So I would urge you to check out those links. Assume everybody's going to get a copy of this presentation.
Yeah, I'll post all the slides and everything as well as the video.
Okay. And if you think it's of any use, I can put my processing icons into. I mean, it pretty much lays out my whole post-processing steps.
I would appreciate seeing those icons. What's
Okay.
in?
All right. Any questions? I know that's a lot to go through.
Hey, Dale, I've been thinking about putting together a processing machine myself. Would you mind if I sent you an email with some questions and stuff about your choices?
Well, the choice that I made was the AMD. Then the 50.
Your voice is cutting out on us.
I wanted the 32 logical processors, and that was up from 8 in my old machine. And then I really wanted to get that, and they were very hard to get back then. The NVIDIA RTX 3080, which is got like, I think 12 gig of memory in it, and really powerful GPU. That's where PixInsight will shine, is with that GPU, particularly with the AI. Anytime you're doing anything with AI, you really need a strong GPU. Nowadays, I think what is it, 40? There's a 4080 or 4090 that's out now. Still pretty pricey, but I'm expecting those to come down in price. And then I had 128 gig of memory, and then all my working drives are NVMe. So no rotational disks for processing. And it's amazing how much of a difference in processing time it takes. I mean, it's just, several magnitudes.
Yeah, I went from 14 minutes for Blur Exterminator, pardon me, Star Exterminator, down to 28 seconds.
Yeah. The GPUs are monsters. They are absolute monsters.
Well, I've got a 3060 and I'm just wondering whether it's worth going up to more CUDA cores. Like I said, we could take that offline if you want and discuss via email.
If you got a 3060, I think you're in good shape there. I think so I take it you haven't implemented CUDA?
Yes. Oh yeah, I have. Oh yeah. It's
okay.
just mine's a little bit slower than yours, but not a whole lot. And I'm just wondering if it's got to do with the 5950. I got a Core i5 with only 12 logical processors. So I'm not sure whether that makes much of a difference. That small difference.
Yeah, what I can tell you is it's all in the GPU, because if I monitor the CPU and the GPU activity while I'm running Star Exterminator, CPU shows nothing. It's not even being used. It's all in the GPU. So the 5950 helps with pulling the data together particularly when I'm doing weighted batch pre-processing. But it's the post-processing stuff, particularly with the AI processes, that the GPU shines.
Okay, thanks.
Anything else? Well, I hope that you all found this to be helpful.
Definitely.
Thanks much.
You're welcome.
Thanks a lot, Dale. It was great.
Thank you.
Absolutely.
All right. Well, Dan, what do you got next?
I don't really have anything else. If anyone wants to talk about anything, I'm going to go ahead and stop the recording real quick.